Go to this computer. Right. Good. All right. Let me just send a message in the WhatsApp group. Now we start. And then we'll again everybody a little chance now. This and but this is actually a real good turnout. You didn't expect honestly I expected 4 people. Right, join Zoom. Okay, so usually I just do this like by myself, but I say just in case y'all could join in and let me know along the way. From 5 Fatima. All right, that's one. And I should really have one group. Let me joke. All right, cool. All right. So we started with trigs. So our basic things here, right? So we have for right angle triangle like this. This is theta. This is my hypotenuse. This is my opposite. This is my adjacent. Sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. And tan theta is opposite over adjacent, right? Now, that uh, this is my sine opposite hypotenuse. Ka cos is adjacent over hypotenuse. And then tan is tor, right? Which is opposite over adjacent. So we have that there. Now, okay, cool. We're gonna have something called our identities, right? So these are things that you're gonna have to know. So what you need to know, couple of things. Sine squared theta plus cos squared theta is 1. And we can prove this. All right, so how do we prove this? Oh, we also know that hypotenuse squared is opposite squared plus adjacent squared. All right, this is Pythagoras. Now, the proof for why sine squared plus cos squared is 1. Do they really bring it? No, but it's still something you should know, right? So we know that sine theta is opposite over hypotenuse, and cos theta is adjacent over hypotenuse. So if I was to substitute opposite over hypotenuse squared plus adjacent over hypotenuse squared is equal to 1. And we'll get opposite squared over hypotenuse squared plus adjacent squared over hypotenuse squared is equal to 1. If I multiply everything by hypotenuse, we'll get opposite squared plus adjacent squared is hypotenuse squared. And that's essentially the proof. You could use that. We could use another one. Now there's another one we covered as well, but this is really the one that they want, right? So I'm gonna say this is my first proof, this is my first identity, and this is the proof. Um, my second identity is sine theta over cos theta is equal to tan theta. And the proof for that one is that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So let's make opposite the subject here. So sine theta by hypotenuse is opposite, and cos theta by hypotenuse is adjacent. And if I use this, tan theta is opposite over hypotenuse, sorry, opposite over adjacent. Which is from this sine theta by hypotenuse over cos theta by hypotenuse. That cancels with that. You'll get sine theta over cos theta. Now, again, these are things, as I said, you don't really need to know, but still, since we're doing a comprehensive review, you'll see it here. You can refer to it in the video. All right. That's all. So me and two ones, so we don't stray from it, is 1 sine squared theta plus cos squared theta is 1. 2 sine theta over cos theta is tan theta. And this works for all powers. So example, sine squared theta over cos squared theta is tan squared theta, right? Same thing, it always works. Okay, now we have something here called the double angle formulae. So we have sine 2 theta, 2 sine theta cos theta. Cos 2 theta is 2, well, cos squared theta minus sine squared theta, or 1 minus 2 sine squared theta, or 2 cos squared theta minus 1. Right now, where you get that from? When we do the multi-angle formula, you'll see it. Okay? Now, and the other one, tan 2 theta is 2 tan theta over 1 minus tan squared theta. Note, we can derive these. However, it is easier to memorize. I'm being real honest. Easier to just memorize these, right? Now, to move, especially with cos, we would use this to kind of get these. Another thing I should note here as well on the topic of this is that we could rearrange these and branch off into two things. We could say sine squared theta is 1 minus cos squared theta, and cos squared theta is 1 minus sine squared theta. We'll branch off into that. Now we also have the multi-angle formulae. And note, these are given in Formula sheet. Okay, so do I have a formula sheet here? Yeah, I do. So come here, right? They actually give it. They give it them here. So you don't have to worry too much about memorizing these. You just they'll give it them, right? And sine of A plus B, sine A cos B plus cos A sine B, sine of A minus B, sine A cos B minus cos A sine B, cos of A plus B is cos A cos B minus sine A sine B, cos of A minus B is cos A cos B plus sine A sine B, tan A plus B is tan A plus tan B over 1 minus tan A tan B, and tan A minus B is tan A minus tan B, 1 plus tan A tan B. And I said, the given to any formula sheet, right? So you're not a business too much about memorizing these. But something to note here is that we can derive the double angle formulae using these. So what I mean by that? So for example, sine 2 theta is equal to sine of theta plus theta. Hold on. Trying to get who some in. Right. Sine of theta plus theta, which is sine theta cos theta plus cos theta sine theta, which is sine theta cos theta plus sine theta cos theta, which is 2 sine theta cos theta. So as I said, right, you could derive them, but again, for me personally, and I think for the rest of y'all, just I would say learn off the double angle formulae, right? That's a lot easier to do that than trying to derive it in the exam. That being said, though, you have it in the exam, you go through. You can time yourself, you'll know what you'll be able to do, right? So, see, next, we're doing graphs. Y equals sine x. Looks something like this. All right, so we have 4 major points. Technically 5, right? This goes to 1. This goes to minus 1. This here is 90 degrees. This here is 180 degrees. This here is 270 degrees. And this here is 360 degrees, right? If we make a note here, 90 degrees, it's pi over 2 radians. 180 degrees is pi. 360 degrees is 2 pi. All right, cool. Y equals cos x. Looks something like this. No, I know I'm moving a bit fast, but that's because I know y'all would also have time to look at it in the video as well. All right. Cost looks something like this. So, 4 points here, this point here, this point here, and this point here. So this is 1, 0, -1. And this one I'll put the radians pi over 2 pi, 3 pi over 2, 2 pi. All right. Then I have y equals tan x. Now, tan x is the weird one. So we make 4 like this. So this is pi over 2, pi, 3 pi over 2, 2 pi. It goes like that, then like that, then like that. So notice here it have no values on the side here, right? So it goes to infinity and then back down to minus infinity and so on. Note, a graph can have the form y is equal to a, in capital A sine bx. This here tells us well, you all know it as what? Crescent trough, right? But that's
Yeah.
my peak and dip. So peak and dip. And this tells us the number of cycles in 360 degrees. So what does that mean? So like if y, for example, if y is 2 sine x, it would look something like that instead. So you'll go to 2 and -2 because that's my new dip, right? And this will be pi over 2, pi, 3 pi over 2, 2 pi. If I have y is sine 3x, that means I have 3 cycles. Oh, let's make it easier for me, right? 2x. I'll have 2 cycles. 1, 2. That was still bad, right? It'll still go to 1 and -1. But in this case, this will be what? Pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi.
So, and for ones like these, though, we could just draw one cycle, but show that the units are like reduced.
Correct. Yes. So
So
what
now the
Michael's
number 7. Yeah.
so what Michael is saying is correct. What I could have done was essentially done something like this, right? Where if I wanted to, I could have just draw that part of the graph, just one set, and show that those are my bounds. But it's good practice to at least know how to do this, right?
So,
So,
so whenever they ask you a question,
uh-huh.
like you have always has to equal to 2 pi at the end.
Yeah, I understand what you're saying. Yeah, you actually no. You could just draw one cycle if you want, right? But it should always have at least a full graph. So you can't draw something like this. It can't be like that, where you only put like half a graph. It needs to have at least one full revolution of the graph. So that's a good question. So like if you did this, that's acceptable. So like if you did this, that's fine. But if you did something like this, where it's only like half a graph, nah. So you don't necessarily need to go to 2 pi. You need to go as far as you can um complete a whole cycle.
Oh, so just like one revolution where you
Yeah,
stop at pi for the second one will be fine.
yeah, correct. Right? Now, on the rare chances, the question itself could tell you to sketch between 0 and 2 pi or 0 and 360 degrees. In that case, well, you would know obviously to go to the point they tell you to stop at. But if they don't define that, then you're good to go. Right?
And then so to get those same values there, what we just multiply by whatever the b is, or like by a
Well,
half.
divide by b.
Okay.
Yeah? So I divide each term by b. So those are my notes there, right? So note to get peak and dip, multiply by a to get values on x-axis, divide by b, right? Couple things to note from these graphs. Note one, sine theta and cos theta are bounded. Bounded is not the right word, but because bounded has a different meaning in math. But for now, for what you understand, sine theta and cos theta are bounded between -1 and 1 inclusive. So, for example, sine theta equals 2 has no solution as
So the curve just got past the -1 and +1 values.
yes, as sine theta is between -1 and 1, right?
And so that's for, and we have to know that for the quadratics too. Like if we
Yeah.
get one of the values is 2, when you
Hmm.
do that, you can't
Yeah.
use that one.
But the thing is, right? The funny thing is like even if you work it out, when you reach a calculator and you do sine inverse of 2, you're gonna get error 2. So you don't necessarily need to learn it off, but it's good practice to know it will save it like it'll save you a
Yeah.
minute in the exam, right? Second thing, 2, tan is unbounded. So tan theta equals 100 as a solution. 3, tan 90 and tan 270 are undefined. They have no values. Okay? Right? So these are things you need to know when you're solving them. Right? I'm sorry, this thing keep rotating, huh? Well, let's see if I could put on yeah, rotation lock. Right, good. One day I'll learn how to use iPad, you know. Right. So now we get into something called exact values. So we not even get into equations and thing yet. I want to, if you realize, the main focus does usually be equations, but it have so much more that they could ask. By the way, guys, you're hearing me clearly, right?
Yeah,
Yeah.
sometimes they're breaking up.
Sometimes. That's
Yeah,
you or me?
like when I think I don't even know. Sometimes it's saying the host connection, then is my connection.
Oh, okay. What would you say, y'all?
I
Good.
find it's
I
fine.
hear you, sir. I hear you good, sir.
That's good, sir.
All right, well, Bryson boy, how look, all right? Sorry about that. All right, so exact values. So there are certain values of trig functions that you're supposed to know the value of. Now, back in the day, again, you didn't have a Casio calculators, so you needed to learn these off because you had the third form. But now that you have the Casio calculators, you get it one time. So theoretically, you don't need to learn these off, but we'll do it, right? So we have a table. So you'll have 30, 45, 60, 90. So we have sine theta, cos theta, tan theta. And we have 30 degrees, or pi on 6, 45 degrees, pi on 4, 60 degrees, or pi on 3, and 90 degrees, pi on 2. So sine of 30 is a half, cos of 30 is root 3 over 2, tan of 30 is opposite over adjacent, 1 over root 3. Sine of 45 is 1 over root 2, or root 2 over 2. Same thing here, 1 over root 2 over 2. And this is 1. Right, then we have sine of 60 is root 3 over 2. Cos of 60 is a half. This is root 3. Sine 90 is 1. Cos 90 is 0. And this one is undefined.
Nina! Nina! Tyrell!
It's,
good or what?
it's Gailey.
You good? Mr. Nina, is he seeing me?
Right, let's try that again. Right, so we have the triangles that we learn off of these, right? So if this is 30 degrees, then this would be what? 60 degrees, right? And we just need to learn off these triangles, because if sine 30 is opposite over hypotenuse, this is 1, 2, and this would be root 3. I can obtain these triangles pretty easily, yeah? Like with um you can learn these off pretty easily, just memorize them. But at the same time, you have your Casio calculator, so you don't really need to worry about these.
When will we use these though? Or it's just the next period I can remember them.
No, so I'll show you what I mean, right? So, and we have this is 45 degrees. This is 45 degrees, so this would be 1, 1, root 2, right? And you could get those from there, right? Chris, I appreciate your sacrifice because trust me, I know the same thing. I was catching real traffic too. Right. So let's see. How do we use exact values? So using exact values in solving trigs. So they would say without the use of a calculator, find the exact value of cos 105 degrees. Now, you would just put it straight in the calculator and get it, but that's not what they want. So they would want something like this. So 105 degrees is the same as 60 degrees plus 45 degrees. So you'd have to do cos of 105 is equal to cos of 60 plus 45, which is cos 60 cos 45 minus sine 60 sine 45, which is cos 60 is a half by 1 over root 2 minus root 3 over 2 by 1 over root 2. So this becomes 1 over 2 root 2 minus root 3, 2 root 2, which is 1 minus root 3, 2 root 2. That's what they want, right? And that's how we'd use the exact values in solving trigs. You would have to find like the sum or the difference to get this, right? So just y'all try it. Now try this one. Find the exact value of sine 15 degrees. Try that one. All right. So this here, 15 degrees is 60 minus 45, which would be sine of 60 minus 45 is sine 60 cos 45 minus cos 60 sine 45, which is root 3 over 2 minus 1 over root 2, sorry, by 1 over root 2 minus half by root 2 over 2, which is root 3 over 2 minus 1 over 2 root 2, which is root 3 minus 1 over 2 root 2. All right, so that's what they want from you essentially. And again, your calculator will give you the value, but you'll lose marks because they want to see you working. Okay? Right. So
You just had to
another
memorize it.
was that?
So you just had to memorize the exact values.
Yeah, yeah. So you just have to memorize 30, 45, and 60. That was the three you need to know. Right.
So and you're
Uh,
gonna use also sine 45 minus 30.
mhm. You could have
Yeah.
used 45 minus 30 and you get the
I
same
got
answer.
I got a different answer. I got 2 minus root 3 over 4.
We get 2 minus root 3
Over 4, yeah. I ended up with sine 45, cos 45 minus cos 30 by sine 30.
Oh, you be dealing with sine. Why you use cos for?
Well, the same thing how was this sine A minus B, so sine 45, then cos 45
What?
minus
No,
cos
no,
30
no,
by
no.
sine 30.
No, brother. You did sine 45 minus 30, which is
Yes.
sine 45 cos 30 minus cos 45 sine 30,
Oh, okay, my bad.
which is 1 over root 2 by root 3 over 2 minus 1 over root 2 by a half. Yeah, you get the same thing. Root 3 minus 1 over 2 root 2. Yeah. All right, just watch your formulas, right? So it could happen to Michael. Just watch your formulas.
Yeah. I mean, so the A's and the B's, that's why, yeah.
Mhm. Right. So we still ain't get to equations yet. The other thing we have to do now is something called finding values of sine, cos, and actually no, let's not do that. I should do the equations first because we have to deal with quadrants. So solving trig equations because we first had to do the quadrants, right? Solving trig equations. So let's look at the y equals sine x. Look something like this, right? If I was to draw a horizontal line, you would notice, draw a straight line here. You would notice here and here have two intersections. So every trig function has, well, should have two solutions. You have a couple exceptions like 90, 180, 270, 360, right? You have those exceptions, but not. So every trig function has two solutions, right? So how do we get these solutions? These solutions,
Quadratic.
yeah, but are dependent on quadrants. So the whole thing, we have our quadrants here. So quadrant 1, this is between 0 to 90 degrees, or 0 to pi over 2. All angles, well, all are positive. Theta is equal to alpha, right? We have quadrant 2, which is 90 to 180, or pi over 2 to pi. Sine is positive, cos and tan are negative. My theta is equal to 180 minus alpha, or pi minus alpha. We have quadrant 3, which is 180 to 270, or pi to 3 pi over 2. So tan is positive, sine and cos are negative, and my theta is 180 plus alpha, pi plus alpha, and quadrant 4 is 270 So 360 or 3 pi over 2. So 2 pi. Cos is positive. Sine and tan are negative. And my theta is 360 minus alpha, or 2 pi minus alpha. And alpha is the positive acute angle. Right? And so you just remember it like this, right? ASTC, whatever you remember it as, go through. Right? Now our steps. Steps. 1. Determine what quadrants the solution lies in based on the trig function and sign of the value. 2. Make value positive and solve for alpha. 3. Use quadrant formulae from 1 for get solution. I want you to note something here, right? Note, you will never find the inverse of a negative number. So like if you have sine alpha equals -1, this is a no, right? You'll never get that. So example, sine theta equals -1/2. Sine is negative in, so I'll draw my thing here, ASTC, in 3 and 4, quadrant 3 and 4. So now I've put sine alpha is equal to what? 1/2, right? So alpha is sine inverse of 1/2, which is 30 degrees. And theta is in quadrant 3 and 4, which is 180 plus alpha and 360 minus alpha, which is 180 plus 30 and 360 minus 30, which is 210 degrees, 330 degrees. So notice here, you'll never find the inverse of a negative number. If you find the inverse of a negative number, you do something wrong, right? Just remember that. If you find the inverse of a negative number, you're doing something wrong. All you're doing here, you determine what quadrant it's in, right? Because it's negative in quadrant 3 and 4. Then I solve for alpha. Alpha is just you make the number positive and solve for alpha. And then you apply the suitable formulae. It's a foolproof way to do it, right? So just to make sure you all get it, example, do cos theta is -1/2 for me. And put your answer in the chat. You could just PM it to me, right? Give you all a couple minutes. All right, so I'm getting the right answer, right? 120 and 240. You do it correctly. Okay. So cos is negative in 2 and 3, right? So cos alpha is a half. Alpha is cos inverse of a half. It's 60 degrees. And theta being in quadrant 2 and 3 would be 180 minus alpha, 180 plus alpha, 180 minus 60, 180 plus 60, 120 degrees, 240 degrees, right? So that's essentially it there. Now, then we have our disguised quadratics involving trigs. So something to note here, sine squared theta is the same as sine theta all squared. So steps is 1, let y equal to your trig function. 2, obtain quadratic. 3, solve quadratic. 4, resubstitute y as trig function. 5, solve trig function. Right, so for example, sine squared theta minus 2 sine theta plus 3 equal to 0. We should put this as minus 3. Try this one now. Let me see what you all get.
Is there any reason here we put it as a y and not x?
Michael, that's just been difficult. You could put it as X, Go ahead, dog. You put it as X. Now, the reason why, actually, no. It's a good. Sometimes it's put sine squared X and thing, and they'll ask you to solve for X. They hardly ever put sine squared Y and so on. So, usually I use Y, but in this case, if you want to use X, you go ahead. It really matters.
And I could just scroll up all with no 2 seconds.
Mhm. Right there?
Oh, never mind. No, you see, I thought I was rubbing mine. I thought I had more now.
Oh, all right. No problems. All right. We have it there. Kyle, if you forget editing any of this video, nah, I going this getting uploaded straight as is.
No, man.
Right, if you did correctly, you should get 270 degrees. Okay, well, I'll give you a couple more minutes again. All right, so again, if you did correctly, you should get 270 degrees. All right, so we just have a couple more things to do after this. We gotta do the triangles thing and then the proofs, and that's it, right? We're going on long enough as is, right? So as I said, you let y equals sine theta, so you get y squared minus 2y minus 3 equals 0, which is y minus 3 and y plus 1. So y minus 3 is 0, y is 3, y plus 1 equals 0, y is minus 1. Don't forget to resubstitute. Sine theta is 3, sine theta is minus 1, so we know it can't be this one, right? So sine is negative in quadrant 3, 4. So sine alpha is 1. Alpha is sine inverse 1, which is 90 degrees. So theta is 180 plus 90, 360 minus 90, which is 270 degrees, 270 degrees, which is just 270 degrees. And that's how you do it, right? So you make whatever trig function it is y, you'll get a, what do you call it, a quadratic, solve the quadratic, and that's it. Couple things to note here though, right? Now again, if you have to get the notes and so on, I will I'll post this book onto Google Classroom, as well as you'll have the video, right? Couple things to note. We must have the same trig function in the equation to solve. right? If not, we will have to convert sine squared theta to cos squared theta or vice versa. All right, so for example, if I have cos squared theta minus sine theta, make sure I go work out. Plus 1 equal to 0, right? That work out. Let's see. Yeah, that work out. Right? So if you have something like this, you can't just let y equals cos theta because it won't go out sine theta, right? You'd have to do something like this. You'll have to know that cos squared theta is 1 minus sine squared theta. And you get 1 minus sine squared theta minus sine theta plus 1 equals 0. Minus sine squared theta minus sine theta plus 2 equals 0. And you could solve that, right? Now, I'm in the interest of time, I'm not going to solve it, but you get the idea. You have to make sure that whatever you're working out has to be the same trig function, right? Likewise, the value inside the trig function must be the same. So for example, if I have cos 2x minus sine squared x, or let's say minus cos squared x equal to 1 or equal to 0, you have to convert then. You'd have to know that cos 2x. So what I mean by the value inside has to be the same. Notice here, this thing here and this thing here aren't the same. So you're going to have to convert my cos 2x is 2 cos squared x minus 1. So it's become 2 cos squared x minus 1 minus cos squared x equal to 0. So you get cos squared x minus 1 equal to 0. And you could solve that. So let me repeat that. You have to make sure that 1, you're dealing with the same trig function and you're dealing with the same value inside the trig function. Okay? That's just something you ought to know. Now, solving unknown angles using triangles. So what I mean, it was actually a pretty hefty question last year. So I feel like this is the direction they're going. We need to remember a triangle like this, theta, right? And we have opposite, adjacent, hypotenuse, right? Sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. Tan theta opposite over adjacent. And we know hypotenuse squared is opposite squared plus adjacent squared. So what do I mean? So example, given A is acute, and sine A is 4/5, find the value of cos A. What does that mean? So it helps to draw the triangle. This is A. 4 is my opposite. 5 is my hypotenuse. So this is 4 and this is 5. So I need to find my adjacent side. And we know hypotenuse squared is opposite squared plus adjacent squared. So that would be 5 squared is 4 squared plus adjacent squared. So 25 is 16 plus adjacent squared. 25 minus 16 is adjacent squared. 9 is adjacent squared. Square root of 9 is adjacent. So the adjacent is 3. So this is 3. And then cos theta is adjacent over hypotenuse, which is 3/5. So in these cases here, you have to draw the triangle, find the missing side, and that's your answer there. Okay? Do not find the inverse, right? Do not find the inverse. Couple things. Note. We use Pythagoras to solve. 2, do not find the inverse. 3, acute means all are positive. 4, obtuse means sine is positive, but cos and tan are negative. Okay? So these are the things you have to note. All right, let's do one question like this, and then we'll get into proofs, and then we'll call our night, right? Because again, a little late. Example. Given cos A is equal to 4/5. Actually, let's change it up. 3/5. And sine B is equal to 12/13, where A is obtuse and B is acute. Find the exact value of 1 sine A, 2 cos B, 3 sine A plus B. Try that one. And then send me answers in the chat. Right? So this is a little different. We did something like this in class, but very little. Right? We did very little of this in class. So, and again, the reason why I usually save it for times like these is so that, you won't forget it. Right? Right, so when you finish, just give me the answer for 1, 2. Shit, no. A can't be obtuse. Sorry. Change this to B is obtuse and A is acute. Right? Change it to that. That would work out better. Yeah. Now, Michael, so it's not the same triangle, it's two different triangles. So you have to draw them differently.
Oh, I was real confused. Okay, I see, I see.
Cool. Like men struggling with this one, right? Well, I'll give you 11 minutes again, and then we will do it. Just remember your cos B will be negative because it's obtuse, right? All right, so let's look at it, right? So remember I say you draw the triangles. So that'll be for A. So the adjacent is 3 and this is 5. So 5 squared is equal to 3 squared plus x squared. 25, 9 plus x squared. 25 minus 9 is x squared. 16 is x squared. So x is the square root of 16, which is 4. So this is 4. So that means if sine A is opposite over hypotenuse, which is 4 over 5. Good. Next one. Draw a triangle like that. This is B. And I said sine B, this is 12. This is 13. So 13 squared is 12 squared plus y squared. 169. It's 144 plus y squared. All right, so 169 minus 144 So y is the square root of 25, which is 5. So this is 5. My cos b would be 5 over 13, but it's obtuse, so it'll be negative, right? Now, there's a reason behind it. If I draw if I show you what it looks like in the quadrants and thing, it would make sense, but it's a lot easier to memorize that what is obtuse, cos and tan is negative. Just remember that, right? So you get sine A and cos B. So now we'll have sine A plus B is sine A cos B plus cos A sine B. So sine A is 4 over 5 by minus 5 over 13 plus cos A is 3 over 5 by sine B is 12 out of 13. So this is minus 4 over 13 plus 36 over 65 over 65 minus 20 plus 36. So you get 16 over 65. All right, so again, this is like a new concept, right? Because you didn't do as much practice in this, if any at all. But again, the reason why we save it for so close to exams is because this is something you all would remember, okay? Right.
So this time, one more time, how come the 5 is negative?
Because once it's obtuse, once the state is obtuse, means sine is positive, but cos and tan is negative, right?
Oh, okay.
Right, cool. All right, proofs. Last thing, proofs. So proofs is this is the break it down of a trigonometric expression into a desired form. So guidelines, I guess. Should put tips, right? Tips. 1. Start with the side.
So definition come in exam, right?
Definitions. What do you mean definitions?
You mean if they're going to ask you in the exam, what is a proof or define a proof?
No. They'll never do that. It's just me being clear on what it is, you know. Nah, they'll never ask the definitions and that, but I'll only be in statistics, right? And then statistics, it'll be like, what is an advantage of using stem and leaf, etc., right? So some tips start with the side with more terms. Try to break down. To get desired trig function. 3, ideally work with sine and cos only. All right, is realistically that's all that they would really want you to do, right? Now, An example would be prove 1 plus 1, I should say actually 1 minus 1 over cos squared theta is tan squared theta. Let's make sure that works out. So that'll be cos squared theta minus 1. That should be the other way around. Minus 1, right? So how do we approach something like this, right? So my left hand side, I start with my left hand side. Why am I starting with my left hand side? Because it has more terms, right? So I have 1 over cos squared theta minus 1, right? Secondly, I am trying to work in sine and cos only. Now, there's many ways you could tackle this, right? So I'm going to show you different ways. And then you all would say, oh, well, if that makes sense or if it don't make sense and so on, right? So I know that I have no 1 in this solution here, right? So I'm going to break down everything. So this is sine squared theta plus cos squared theta over cos squared theta minus 1. I separate the fractions. I'll get sine squared theta over cos squared theta plus cos squared theta over cos squared theta minus 1. I know sine squared over cos squared is tan squared. Tan squared theta. Cos squared over cos squared is 1 minus 1, which is tan squared theta. Or I could say, oh, well, in my thing, I only have 1 term, right? You could do either or. You don't have to do both. Once you get the solution, that's it, right? Showing you another way. You could say, well, this here, my right hand side have only 1 term, so I go and find the LCM, right? So I find the LCM here, cos squared theta. So this becomes 1 minus cos squared theta. And I know 1 minus cos squared theta is sine squared theta, or cos squared theta, which is tan squared theta. Either one is accepted, right? I just draw the square on the end just to say that you finished the proof, right? As I said, it's just something that, you honestly is practice, practice, practice. And because they remove sec, cosec, and cut off the syllabus, it's not much they could bring, right? Um, I'm gonna do 1 and then we'll close off the class, right? 1 because we went past 10, right? Prove uh sine 2 theta over sine theta minus cos theta is equal to cos theta. Prove that, right? Obviously, I won't tell you to put your answer in the chat because just everybody gonna get the same thing. But I want you all to try this one, see what y'all can come up with, right? And then we'll see. Okay, so let's do it, right? So we start with left hand side again. It start with side more terms. Obviously, if you just have cos theta, sin theta, or tan theta on one side, it's real hard to start with that side. So you just pick the other side, right? So sine 2 theta is 2 sine theta cos theta over sine theta minus cos theta. I'm gonna cancel with that. You get 2 cos theta minus cos theta, which is just cos theta. Right? So that's essentially how you do it. Okay. So this is a
So
very
you
productive
know
session.
sine square theta.
What's that?
You wrote it
I
like
put squared,
sine
but I
square
sit on
theta.
it for so long trying to get it. I put
No,
sine
it's sine
squared.
2 theta. It's sine 2 theta.
Oh my
I don't
God. You
realize.
might have to invest in some penmanship lessons, though.
Yeah, probably, you know. That's actually sine alpha theta. Yeah. That's why. Well, look at that. See something? No, I'm just
I thought it was just tricky. I still looking at like what?
don't just see
It
something.
was sine 2 theta.
Yes, I put squared too, dog.
Nah, boy.
Michael, to be
Nah,
fair,
boy.
Sir did say sine 2
Yeah, like,
theta.
I know it have a man in this chat who gets, right? And he knew what I wrote. I get a PM and I know he gets. So I ain't looking for a lot of long talk. But all right, fine. Right, fine. Fair. Right? Cool. Sign to theta. My bad. My bad. I will be the bigger man and apologize. All right, guys. So let me stop the share here. Okay, so that brings an end to our trig program, right? So I hope this was beneficial to you guys. I'm gonna upload it to
Of
YouTube,
course.
right?
I'm
I
asking
wanna
how much gigs are taken up.
nah, dog, this thing have a 2 TB SSD, so I'm good,
What?
right? Yeah, obviously I have 2 TB SSD, so don't worry yourself. I'll upload it to YouTube. Should be out in the morning at least. I'll leave it to render for the night, and then I'll upload it and send you all the link. I want to do a couple more classes like this, to be honest.
Yeah, like sectors.
Sectors, and I think, dog, dog, sectors real easy. Just don't beat up too much about it. Yeah, I want to make a couple more classes like this. Hopefully I'll let you know what dates as well. Definitely after
Yeah.
mocks, dog.
And pure maths too.
And what?
Pure maths.
Only man real fright for this mocks, boy. Hey, the mocks not bad. Don't worry yourself, now, man.